Yesterday we talked about how to graph our initial parent function of sine and cosine. If you weren't here yesterday, we started there and we said it's like this is an algebra 2 skill, so hopefully it's a little bit familiar, but it's so important because when we get to the next section, we're going to learn how to graph secant and cosecant, and those are literally piggybacked on to sine and cosine. If you don't know those, you can't do the next part, okay? So we talked about the sine curve having this shape. It starts at 0, goes up to the amplitude, down to 0, down negative amplitude, back up again. We said that that pattern would repeat on forever both directions. We talked about the amplitude and period. The amplitude is the absolute value of A. That's how high and low it goes. And the period is how long it takes to complete one full cycle. And you find the period by doing 2 pi over B. We talked about the process. So yesterday we did absolute value of A is my amplitude. 2 pi over B is the period. And then we found the key points. And today what we're adding is number 4, which is we're looking for a phase shift. So if you've got something inside parentheses with the x, this causes, like if you think about every other parent function, this causes a horizontal shift. And it's always the opposite direction. So the way we do it with a trig function is we find the phase shift, and then we take our key points and we add or subtract the phase shift on them to shift them right or left. And then we do everything else we already did yesterday. Plot the key points, draw the curve, look for the vertical shift and the reflection, and then shift the points up or down or flip it upside down, God bless you, if there's a reflection. All right, so this, I don't remember what slide this is initially, but this is what we skipped yesterday. So the graph of y equals a sine of bx plus c, and it could be also cosine there, has a phase shift, a horizontal shift. It literally takes my graph and it adjusts the starting point. So if the phase shift is if in this case, if it was a minus in between, we're going to find the phase shift by setting it equal to 0. We would add the c, divide by b, and that point is where we would now start our graph. So notice it's no longer on the y-axis. If the initial equation is minus, we're going to shift it to the right, so we'll start to the right of the y-axis. If the initial equation has a plus, then we would solve it. We get a negative phase shift, and we would shift it to the left. Same would be true for a cosine, except the cosine would start at the amplitude at that point. It would be shifted off of the y-axis. So an example would look like this. It says determine the amplitude, the period, the phase shift of the following, and then graph the function. So let's start with the same order we've been doing. Our A is what? 2, which is the amplitude, right? Absolute value of A is the amplitude. What's the B this time? 4. The period would be 2 pi over 4, which is pi over 2. If I compare this with the parent function of sine, this means this is more narrow, right? Because this is actually, your full curve would have to happen in the horizontal distance that is 1/4 of your initial one, because pi over 2 is your quarter point, okay? Now I'm going to start at 0. I'm going to end at pi over 2. And then I'm going to take my pi over 2 and multiply it times 1/4, times 1/2, and times 3/4. I get 0, pi over 8, pi over 4, 3 pi over 8, and the last one at pi over 2. Now those are your key points without the phase shift. As soon as you see the parentheses with an x added or something added or subtracted from the x, hopefully that's your indicator that there's a phase shift. So I'm going to take that 4x plus pi, I'm going to set it equal to 0 and solve for x to get the phase shift. So I'm going to subtract pi, 4x would equal negative pi, divide by 4. So my phase shift is negative pi over 4, which means I'm shifting all these points left pi over 4, which is consistent with my original being a plus. I go the other direction, okay? So now I'm going to go to all 5 key points and subtract pi over 4. If it was a positive, I'd add it. Negative, we subtract it. So 0 minus pi over 4 is negative pi over 4. Pi over 8 minus pi over 4, I have to find a like denominator. This becomes 2 pi over 8. So pi over 8 minus 2 pi over 8 is negative pi over 8. Pi over 4 minus pi over 4 is 0. 3 pi over 8 minus pi over 4, change it again. So this becomes 2 pi over 8, and I get pi over 8. And pi over 2 minus pi over 4, I got to give it a like denominator. So it's 2 pi over 4 minus pi over 4, which is pi over 4. And now these 5 adjusted points are your key points on the x-axis. Plan ahead, because if you look at them, you've got 2 negative and 2 positive. So you want to give yourself space on either side of the y-axis this time. I'd get negative pi over 4, negative pi over 8, 0, pi over 8, and pi over 4. With me so far? Yeah, what was our amplitude? 2. So then I'm going to mark that on my vertical axis. And what are we graphing, sine or cosine? Sine. Where does it start? At the axis or at the amplitude? Good. So I'm going to start it at 0 at the very first key point. I'm going to go up to the amplitude at the next key point. I'm going to come back down to 0. I go to the negative amplitude. I come back up to 0. And I connect my points. If there was a vertical shift, I would shift it up. If it was reflected, sorry, I would shift it up or down, depending on what it is. And if it was a negative on the front, I'd flip it upside down. Questions on that one? Okay, are we good to here? So A was 1/2, which means that your amplitude B is 2. The period's 2 pi over 2, which is pi. And then there is a phase shift this time. I'd set 2x minus pi over 2 equal to 0. Add the pi over 2, divide by 2, and your phase shift is pi over 4, which means I'm moving everything to the right, pi over 4. So then I'm going to find my key point. So I start with 0. I take my period and multiply times a fourth, so pi over 4. By a half, pi over 2. By 3/4, 3 pi over 4. And then the last one is the original period. Then I'm adding pi over 4 to each of these because I'm shifting them to the right. Pi over 4. So my first one becomes the phase shift. The second one would be 2 pi over 4, which is pi over 2. Then this becomes 2 pi over 4, so 3 pi over 4. This would be 4 pi over 4, which is pi. And this would be 4 pi over 4 plus pi over 4, so 5 pi over 4. Now everything's to the right of my y-axis. So I'm going to start at pi over 4, go to pi over 2, 3 pi over 4, pi, and 5 pi over 4. And what are we graphing this time? Sine or cosine? Sine again. Amplitude's a half. So we start at 0, we go up to 1/2, down to 0, negative 1/2, back up to 0. Raise your hand if you got it right. Okay, good. Questions? Sure.
So why do you add the 1 on the axis?
Oh, I just marked it because that's what originally would be 1. As long as you have your amplitude, it's fine. We talked about the overall shape. Now we start at the amplitude. We go down, down, up, up. Cosine yesterday, we talked about what happened if there's a vertical shift or a reflection, okay? So I actually want you to take this one and I want you to subtract 1 from the end. And then go all the way through. So start to finish on it. Find the same things. All right, we should have gotten to here, right? So absolute value of A is 2, that's your amplitude. B is 3 periods, 2 pi over 3. And then in the pink over here, I did the times the fourth times the half times 3/4. And you get the first initial points would have been 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. But there's a phase shift, pi over 3, positive. So we shift them all to the right, pi over 3. And now my key points are pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. And then the amplitude was 2, and it's cosine. So without the phase shift, I would start at 2, come down, without the vertical shift, sorry, down, up, and my graph would have looked like this. But there is a vertical shift down 1, which means all of these points shift down 1 unit. And then my final graph should look like this. Questions on it? So test is not till the week after next, but obviously, and we're adding to this, but you on that test, you are going to end up having 3 graphs, 1 sine or cosine, 1 secant or cosecant, which will make sense when we get on Monday, and 1 tangent and cotangent. Within them, you are guaranteed to have all the things at some point covered. A reflection, an amplitude stretch, a phase shift, a vertical shift. Like somewhere in there, you're going to have all those points. So you've got to be prepared to know how to do each of those parts, okay? It won't be like one graph with all of it put together. But between those 3, you're going to cover all those kinds of things. Questions before we move to the last thing? Okay. Talked about vertical shifts already. All right, so here is the last kind of question in this section, and that is a word problem with application to your sine or cosine curves. So it says you're riding a Ferris wheel, your height h in feet above the ground at any time t in seconds can be modeled by. So if you think about, like, if you're riding a Ferris wheel, right, let's say you start at the bottom. You go up to the top, you come back down again. You go up to the top, you come back down again. So that cyclic pattern, much like a unit circle, can be then put on an x and y axis to look like a sine curve, okay? So the Ferris wheel turns for 135 seconds before it stops to let the first passenger off. It says use a graphing utility to graph the model. So take out your calculators. And we're going to plug in this whole model. What mode does your calculator have to be in? Radians. There's no degree symbol on this guy, okay? Okay, so my equation looks like this. 25 sine pi over 15. I used x as my variable because the variable doesn't matter. X minus 75 plus 30, okay? And then I hit graph. So on your standard graph, this is what you're going to see, okay? And think about what's happening. Obviously, we're not getting our full sine curve, but our window's set from -10 to 10. So if you think about the parts of your equation, right, this vertical shift, the 30, is actually where the midline on your graph is because it gets shifted up from 0. And then we added an amplitude of what? What's your amplitude on this equation? 25. So from 30, we went up to 25 from 30, came back down to 30, went down 25, and came back up. So the reason we're not seeing our whole graph is simply because of our window. So I can either choose to zoom out or I can adjust my window knowing what I know about what I need to see. I want my max on my Y to at least go to the vertical shift plus the amplitude. So I need to go 30 plus 25. I'm just going to go to 60 there so that I can see it. That's going to get me the full Y part, right? And then, wait for it. Oh, this is shifted. This would be shifted to the right, 75, okay? Now I get most of a curve. Now I don't get all the way to the right and I don't get all the way left. It's fine. As long as I'm looking at the max height and the min height on this, that's what I need. So the max is going to be at the top of my wave, right? It's going to be all the way up here. So if I want to know the max using my graphing utility, second, trace, go to max. I'm going to go left of the maximum. So I'm going way past it to the left. I'm going right of my maximum. And I'm going to hit enter so it could guess. And it tells you what's your max. What's the max value? No, that's where it happens. But what's the actual maximum? Nope, that's where it happens. What's the maximum?
Oh, 55.
55, right? The maximum is the y value at the maximum point. Yes? Do we all understand that?
Yeah.
Okay. Also think about how that relates to my equation. It is the vertical shift, because that's the midline, plus the 25. Same answer. So 55 is the maximum height. And the minimum, second trace, go to my minimum. Now I want to go to the right-hand side. I want to go left of my min, which actually is anywhere here, but I eventually want to go past it. So I can say this is left, and then I want to go past the minimum. God bless you. And then I'm going to hit enter so it guesses, and it takes you that coordinate point. So what's the minimum value? 5. My min is 5 feet, okay? Which would be the vertical shift, which is the midline, minus the amplitude. But if you just look at your graph, you should be able to find it.